Waalaikumsalam, dengar.
Dengar tak?
Ya.
Okay, right. Okay, today we make revision for test. Okay, test 2 20%. Consider just chapter 3, estimation and hypothesis. Just two chapter now. The estimation and hypothesis. Okay, the time is 3 June. The time is 8 until 9:35 p.m. This month. Okay, test 2. Okay, we look at this is the formula for chapter estimation and hypothesis. Okay, the formula is given during this one, the formula. Okay, this is the formula. If you see this formula is suitable for hypothesis, for hypothesis, for estimation, you must develop how to find the confidence interval for mean and variance. Okay, the formula is given here. The number one is z s bar minus mu divided by sigma square root n. Okay, this one is given. I think you know that the condition how to use the number one, number two, number three, number four. We have until 12 formula. The last one is f distribution. Okay, how to find the value f. Okay. Okay, today we discuss the previous test 2, the pattern of test 2. Okay, we look okay, we look the latest for test. This is test. Okay, this is the latest semester 1 2021. We discuss for question number 1, which formula consider how to this one. Okay, siapa ni? Okay, James, try read. James baca, James. James baca.
Okay. Coating thickness plays a key role in affecting other characteristics such as color visual, indentation, resistance, and surface profile. The painting process consists of a primer coat, color coat, and clear coat. For a certain part, these layers have a combined target thickness of 150 microns. A quality control expert at a factory that paints car parts measured the coating thickness of 12 randomly selected points in micron on one of these parts to see if it was painted properly. Assume that the data follow a normal distribution.
Okay, again. Sambung, continue.
Okay. Construct a 99% confidence interval for the true standard deviation of the coating thickness. And B, construct a 95% confidence interval for the true mean of coating thickness. Hence, can we conclude the average coating thickness agrees with the combined target thickness?
Okay, looks at this is the data from the number one is we have the data. Okay, normally when the data is given, you must find S bar as using calculator. What is the value this one? After that, we can construct 95%. This one construct for true standard deviation. What is the PI for variance? This one you must find what is the value for standard. Okay, for this one, which formula? We have many formula. We have four formula. Which formula? Number 1, number 2, number 3, number 4, 5, 6, 7, 8, 9, 10. Okay, which formula? 11, 12. Okay, which formula? And we want to find CI standard deviation. Which formula? Formula. Okay, for this one, for standard deviation, we must the formula is number Number 11, number 11, using chi, this one, using this chi square, using chi square, this one. Okay, from here we can, the formula is given in 11. From here, you must develop your own. If we want to find the coefficients, it is equal, if you see the formula, it is V and n minus 1 s power 2 divided by chi square 1 minus alpha divided by 2 b, this one. Using this formula, based on this one, we can create the confidence interval. Okay, okay, the number of this one. Okay, number B, constant 95% for true mean. Okay, for this one, which formula we must consider? Number B. Which formula number B? Okay, if you see this one, n is just 12, n is 12. S bar we can find from the data, and S we can find from the data. Okay, which formula for this one? Using Z test or T test? Using T test or Z test? Okay, using T test, for this one, using T test, formula number 3, if you see the formula is number 3. Okay, T it is equal minus mu divided by S divided by S square. Okay, from here, I for mu it is equal S bar plus minus T alpha divided by 2B S divided by square root N, the formula. Okay, okay, you can try for this one. Okay, James, try do question number 1, James.
Okay.
Okay, number 2. Azim has come. Azim.
Ya, saya ada.
Okay, Azim, nanti baca Azim. Number 2.
Soalan nombor 2.
Okay, number 2.
Okay. Many cities are still complaints that their manhole covers are defective, and people are falling into the sewers. The authorities are trying to investigate the matter. It was found that there are 2 companies supplying the manhole covers. Isketambola Inc. and Isketambatu Inc. An officer took a random sample of 800 manhole covers supplied by Isketambola Inc. and found that 40 of them were defective, while from a random sample of 700 manhole covers supplied by Isketambatu Inc., 28 of them were defective. 1. Compute a 95% confidence interval for the difference in the true proportions of defective manhole covers supplied by these 2 companies. Number 2. Hence, is there any difference in the proportion of defective manhole covers supplied by these companies? Give your reason.
Okay, for this one, if you see this one, we want to find 95% confidence in true proportion. For this one, okay, if you see the question, P1 it is equal S1 divided by N1, it is equal 40 divided by 800, this one. And P2 it is equal 28 divided by 700. Okay, for this one, we must using the formula. This is equal SP1 minus P2 minus P1 P greater P2 divided by P1 Q1 N1 plus P2 Q2. Okay, from here we can find with the CI for P1 minus P2, it is equal P1 at minus P2 at. Okay, I think it is P1 Q1 N1, okay, plus P2 Q2 N2. Okay, you can put the value from here. Okay, the number 2, how to determine, is there any difference? How to determine from here? How to determine? Macam mana nak tentukan ada different, have different or not different? Number 2.
Kalau lalu kosong.
Okay, cantik. Look, kalau if P1 minus P2 it is equal 0, it is mean P1 is equal P2 and you look. Okay, Azim, siapa ni? Okay, Azim buat soalan B nombor 2 Azim. Azim, ni terus continue. Okay, Azim. Okay, number 3. Okay, number 3 is data, same data point 1. Number 3, siapa nak buat ni? Okay, go number 3, go. Zhang Heng, go. Okay, go.
Ada.
Okay, Azim, nombor 3. Try baca nama ni.
Nombor 3
Okay, nombor 3.
Manufacturer B aims to improve the pattern of its tires to provide better fuel efficiency and higher durability. To improve design performance, the manufacturer tests the capabilities of the tires by conducting braking distance tests. After the vehicle's braking system is triggered at predetermined speed of 100 km per hour, the manufacturer hopes that the average complete stopping distance for the car is not more than 40 meters. The results from the braking distance tests for 10 stopping distance are as follows. Based on these results, the test an appropriate hypothesis testing by using 0.05 significance level. As a tire manufacturer, would you choose the improved design and why?
Okay, continue. Number B?
Number B, manufacturer B wants to compare the quality of current and improved design by conducting another experiment by running a random sample of 12 tires for both designs until they wear out. The results from the experiment show that the mean distance of the current design is 35,855 kilometers with standard deviation of 4,122 kilometers. In contrast, the mean distance of the improved design is 54 kilometers with standard deviation of 4,925 kilometers. At 5 significance level, is there any significant difference between the average wear of the current and improved design? Assume the populations to be approximately normal distributed with equal variance.
Okay, looks at the number A, 3A. Okay, for this one, we have the data. It is the same which number A. The first you must find the value N and its 10. Okay, from here data, you must calculate the value S and S. Okay, from here, we want to test what is the test the hypothesis. Okay, from here, what is the hypothesis? H1. Okay, H1, mu, this one is 40. Less or greater for this one? Greater or less? Which one? And looks the hypothesis looks H1. Greater or less? Okay, greater or less, this one. And looks the sentences, we want to test, the manufacturer hope that the average complete stopping distance for the car is not more. Okay, not more. What is the symbol not more?
Less.
Okay, less. And put here, the hypothesis looks at 1. This less, this one at 1. What's the formula? N is just 10, S you can count from the data. What is the formula? T or Z? T or Z? Okay, T or Z, this one. Which number? The formula number, what's formula? A, the number 1, number 2, number 3. Okay, and looks and just 10. Okay, number 3. Number 3 is using T S bar minus mu divided by S divided square root N. Okay, you can continue for this one. If you see the marks is very high, 7 mark for this one, very high. Okay, the second, we have two tire. This one type A. This one is type A, tire A. Okay, this one is type B. It is okay. Okay, we want to compare the two tire. Tire B is given the value of N is 12. From N, we can get the mean and standard deviation of tire. Okay, this one. Okay, this is the new question. The new question. We have 12. This one. The second is mid is this one. Then this one. We have two data. Okay, for this one, assume two population approximately normal distribution. When you look, the question is assume equal variance. You must find SP. The value you must using the T SP. This one using the test is S1 minus X2 minus mu1 minus mu2 using SP. This one SP. If you find the equal variance, assume equal variance, you must use the SP. Okay, what is the hypothesis for this one? What is the hypothesis? What is the hypothesis? Equal or not equal or greater less? And look the last sentences. Last sentences. At 5% significant label, there are any significant difference. Significant difference. Okay, what is the symbol? Okay, not equal. Okay, not equal. Equal. Again, not equal. Okay, this one. Okay, Django. Try do question number 3.
Okay.
Okay, question number 4. Okay, Irisa.
Ya, doktor saya.
Okay, baca Irisa nombor 4. Okay, Irisa nombor 4.
Alright. Company X is one of the largest air conditioning manufacturers in Malaysia. A quality control inspection needs to be implemented to ensure customers receive products that are free from defects. Defective air conditioning units will incur high costs to the company since the prices of the products will be reduced drastically. Therefore, to lower the cost of damage, the company aims to make sure that the proportion of non-defective number of air conditioning units should be at least 97%. The company performs a product check on a random sample of 80 air conditioning units in each warehouse and found that 7 of them are defective. Can you conclude if the company has achieved its aims? Use alpha equals to 0.01.
Okay, let's say from here, if you see this one, the percentage normally we consider proportion. Okay, from here, 7 of them are defective. N is 80 is 80, 80, the defective is S is 7. Okay, for this one is non-defective, for non-defective. Okay, you must look at the unit. The unit is very important. This one is non-defective. This one is defective. You must change for this one. Okay, how many non-defective here? S is defective.
73.
73. X is 73. Okay, PE is equal 73 divided by 180 for this one. You must using P is 70, but okay, what is the hypothesis? Okay, P1, this one, 97%. S1, P, P. Okay, greater or less? And look, H1, look H1, this one is 70%. Okay, okay, for this one, less or greater? Greater or less?
More.
More, okay, more. Okay, more. Okay, more, this one or equal, And at least dia tulis dalam soalan tu at least tu more besar. Okay, ni Erisa terus continue sama terus. Okay, kita tengok soalan terakhir ni. Okay. Soalan terakhir. Okay, Lilita nombor 5 Lilita. Nombor 5. Okay, Lilita, read this one.
Okay.
Baca.
Question 5. An automatic coffee vending machine is installed at University X will not be running optimally if the standard deviation of the drink's contents of the cup is less than 7 ml. Suppose that a random sample of 35 cups are taken and the standard deviation is 6.4 ml. Is there any strong evidence to conclude that the coffee vending machine is running optimally at is not running optimally at 1% significant levels?
If you see this question not input as by it is we take the information and is 35. Okay, from 35 we get the standard deviation S is 6.4. Okay, from here looks at the hypothesis. If the standard deviation of the drinking content for the cup is not less 7 milliliter, this one we must consider. Hypothesis is SO. Using variance, variance is equal. Variance is power 2. This one 7 2. H1 variance 7. But what is the symbol for this one H1? Greater or less? H1 less or greater? Okay, this one based on question, less or greater? Okay, not less is okay. This one is greater. Put greater. This one less or equal. Okay, for this one you must using chi-square. The formula is chi-square. S divided by power. Okay, Lilita, you can continue this one. Try this one. Okay, Lilita.
Okay, sir.
Okay, okay. Okay, sementara tu kawan awak buat tugasan we have one assignment one assignment. Okay, buat assignment this one. Assignment. Okay, saya kasih soalan assignment, this one assignment. Okay, hantar dekat sini, hantar link of submission gunakan one. Kena hantar sekarang hari ni. Hari ni kena hantar tugasan ni. Dia dah siap ni kena hantar. Okay, tugasan ni saya dah bulatkan already circle the circle then the red color the chain you must change the number on circle with the number in attendance. In attendance. Faham maksud dia ni? Kalau misalnya attendance if you get the number 1 you change this one is 0.1. If your number in attendance number 2 change 0.2. Faham tak ni?
Tak faham, bro.
Okay, Azim, ni soalan ni kena hantar ni tugasan. This is the link of submission. Lepas tu setiap orang setiap student mempunyai soalan yang berbeza based on attendance, the number in attendance. Saya dah beri attendance tadi, attendance dah tengok kan attendance awak. Cuba awak tengok nombor awak berapa nombor attendance. Looks your number, the number in attendance for example siapa ni? Okay, misalnya siapa ni? Okay, misalnya siapa ni? 42. Okay, siapa? Ahmad. Okey, Ahmad ni nombor 1 Jadi Ahmad tukar itu 0.08 tukar nombor 1. Just change nombor 1. Faham ya Ahmad? Azim, faham Azim? Masalah nombor awak nombor 10 tukar 0.10 this one. Yang circle dia tukar, dari circle. Ini 0.1. Ini sama dia. Yang ni sama kalau nombor 10 dia 10%. Kalau nombor 10 sini 25.2 change number 10. Tukar yang circle ni tukar nombor attendance. Jadi kalau 0.08 ni sama 0.10. Okey, ni yang ni kalau ni 10 letak 10. Change tu jadi 10. Ini kalau 355 change 310. Kalau number 1 301. Kalau number 20 3320. Ada 6 soalan. Tapi skema dah ada, skema ni berdasarkan soalan. Tapi kalau skema ni, awak ikut skema ni soalan dia. Jawapan dah beri dia punya jawapan dah diberi. Tapi awak kena ubah lah sebab dia bila data ubah, dia punya jawapan pun akan berubah. Faham Faham tak Azim? Jadi dia punya skema ni pun awak kena ubah. Ni skema ni berdasarkan nombor yang ada ni, berdasarkan nombor yang misalnya 20, tapi kalau if you change this one, the answer is different, akan berubah. Okay, faham tak kena hantar kalau pengalaman pun hari ni so this based on this assignment. Okay, saya kasih soalan ni. I give you this question. After that, you can do Mana test 2. Okay, ambil you can take the question. After that, you can do for this one. Siapa ada tak faham lagi masa dalam ni? Ada tak faham? Okay, kalau tak faham boleh buat sekarang ni, yang ni, bentuk yang ni. Jawapan dah dia beri, jawapan cuma awak kena modify jawapan ni. Based on the number, the number this one. Number follow in attendance. Okay, Ahmad nama faham tak Ahmad? Ahmad.
Saya ya, kalau yang nombor 1 tu 0.1 kan?
Yang mana? Okey, kalau atas ni kalau nombor 1 awak 0.1 tulis.
0.1 ataupun 0.01.
0.01.
Okey.
Ini kalau yang ni 1%. Kalau ini nombor 1. Ini 1 terus lah sebab dia bulat semua ni nombor 1. Faham Dan ni kalau ni 0.01 sama lagi. Yang lain kalau ni 20 jadi 1. Dan kalau ni 3.301. Okey. Jadi jawapan dah awak cuma follow macam mana dapat jawapannya. Jadi awak kena belajarlah macam mana dapatnya. This is very important for during exam tu. Kalau awak tak buat tak tahu macam mana nak dapatkan. Ada tak soalan lagi nak tanya? Okay, kalau tak ada boleh buat kita buat yang ni. Lepas tu dah siap boleh hantar This one is the link for submission.
Doktor, soalan kat mana doktor?
Ini dah hantar baru dalam WhatsApp. Saya baru hantar.
Okay, thank you doktor.
Okay. Jadi kalau ada masalah boleh WhatsApp saya kita kelas kita stop sampai sini. Jadi buat tugasan lah. Okay. Jadi buat tugas boleh hantar sampai pukul 12 malam ni until submit. Tak kisahlah saya boleh pulang satu hari ni. Okay, submit. 12 mas. 11 lah, 11. PM until today. Kenapa? 12 lah hari ni.
Hantar kat mana doktor?
Okay.
Oh tak ada link. Okay, sorry.
Ada
Okay,
link.
sorry.
Okay. Okay, kalau tak ada masalah kita boleh bersurat jumpa nanti saya tunggu itulah tugasan awak je lah ni. Okay, kalau tak ada kita jumpa lagi pada esok.
Okay, thank you doktor. Assalamualaikum.
Okay, see you tomorrow Okay.
Doktor.
Okay, ada apa?
Doktor, yang saya punya kuis saya tak ambil lagi doktor, saya lupa.
Tak apa, ni kuis ni saya kabur yang ni.
Okay.
Siapa yang tak ambil kuis tak apa, saya kawasan awak ni. Yang penting tugasan buat je okey.
Okay doktor.
Okay. Assalamualaikum.
Salam.
Okay.